quiz before this?
I will discuss on the next lessons, 1 hour. Is it okay?
Okay.
Because I have prepared quiz question for the discussion during the next class. So for today, I'm going to finish the integral form first. All right, and then we will discuss on the question that going to help you during the test one.
Sure.
So today lecture we're going to understand the fundamental law that relates to the integral form. So what is integral? You can see the integral is where we convert from differentiation to the integral form. All right. After that, you will understand why we need the integral form. So two options of studying the fluid flow. The first, we can study the motion of individual particle. Right. Yeah.
Sorry, doctor. I think your mic is mute.
Okay. I think this is okay now, yeah? Okay, let me repeat back. There are two options of study the fluid flow. The first one is we can study individual fluid particle. Okay, we have this one, and then we can see the trajectory, the velocity, the acceleration, all right, of individual fluid particle. Second one, we can study the region of space as fluid flow pass through. This is the region. Okay, that means we need to investigate the space. Okay, what happened inside the region? The fluid will be the interaction of the fluid. So in this chapter, we're gonna review the physical law. Second one, go over maths needed to convert from system to control volume, and finally obtain formula for physical law by combining the result. So let's start with the basic law, conservation of mass, which is okay, the mass of a system is conserved and doesn't change with time. So mass of the system is equal to constant. That means the change of mass of the system over dt equal to 0. So this is m dot system equal to 0. So the dot product represent the time. And Newton's second law on the other hand, if there is a net force F on the system, the mass, the mass in the system will accelerate. That is what we call F equal to ma, or mass is equal to d over dt. This is mass and velocity. Alright, the change of velocity refer to acceleration. And angular momentum, the rate change of angular momentum is equal to the sum of all moment acting on system. So this is the angular momentum symbol dH over dt, where the H is basically the summations of R multiplied with V, multiplied with the small change of mass. So the first law of thermodynamics, if there is a heat, small change of heat Q is added to the system, or work is done by the system, dE, the change of energy must change, because Q is energy, work is also energy. Alright, so according to the equation, it's supposed to be, this is Q, and then this is the small change of heat energy into the system, and then this is the work done by the system. The system do the work, it is negative, right? Equal to dE. So if we want to change into the rate, the work rate, and then the heat rate, so we can be Q dot, that means this is a Q dot is a Q dQ over dt. Alright, Q minus W dot equal to dE over dt. That means this term we divide with dt. This is the, both of this is the system energy. So this is what we call all the system. The angular momentum, the Newton's second law, conservation of mass, all in the system form. Alright. So in fluid mechanics, as I mentioned before, we need to investigate the individual fluid particle as well as the region of space. Alright. So in order to investigate the individual of fluid particle and the space as the fluid flow, we need to consider the control volume, right? So let's say this is the system. So I want to investigate certain region. So I put this way. This is now become my control volume 1. For example, I want to investigate this location. This is now become control volume 2. Alright. So we investigate part by part. By investigating part by part, we can sure understand the behavior of individual fluid particle as well as the fluid flow inside the region of space. So why we use the control volume? As I mentioned before, we need to investigate in detail. So equation above are written for system. As I mentioned before, the thermodynamic, the first law, the Newton's second law, and the conservation of mass is written in for the system. So, look at how beam deflect under load. That means the reason why we need to use the control volume because we need to investigate how the beam deflect under different kinds of load. And also we can study piston as it oscillates. In fluid mechanics, fluid often alter the environment. In which the product operate. So from here we need to know the effect. So in this case, the fluid will alter the, for example, the load coming from this is the beam. Okay, and then, this is the beam. And then we have the wind. So it will bend. So because of this bending, we need to investigate the effects, okay, due to the fluid flow. Thus, we need the basic, right? Thus, we need the basic law to be rewritten to apply to a specific region. All right. So now I will introduce you to the Renault transport theorem, RTT. RTT is used to convert from system to control volume. Alright, we need RTT to convert from the system that you have learned before to the control volume. So fluid system, specific mass of the fluid within boundary defined by a closed surface. Right? For example, the fluid flowing through a constriction. That means the gas is compressed. So a specific mass of fluid within the boundary defined by the closed surface. Shape of the system may change with time. This is very important. For example, we have the nozzle and then we have the fluid. Over the time, as the fluid pass through the nozzle, the fluid will change from here to here. This is the first, and then it will go to the second one due to the time plus delta T. Okay, this is what we call the fluid system. The fluid move. Okay, the system move. This is system. As the fluid move and deform, the system move and deform as well. It follow the fluid. However, for the control volume, it is the fixed region in space which doesn't move or change. Usually select as a region that fluid flow in and out of the closed boundary called the control surface. Shape of control volume is optional, alright? So this is often choose boundary to coincide with some solid or natural flow boundary.
Excuse me, sir.
Yes.
Are you sharing something on the screen because I can't see anything?
Okay, class, are you able to see as well? Are you
Able, Doctor.
No problem.
I think
Yes,
because of
Doctor.
I think because of the internet connection, or please log out and log in again in the Microsoft Office using the same link. And second one, usually make boundaries perpendicular perpendicular to the flow. Alright, basically all this is a summary of the textbook, right? If you read the textbook, all of this it's quite confusing and a lot of detail. So this is the note that I have summarized. I read through the book and I summarize, take the most important point only. Alright, so after this, after you understand all this lecture note, alright, you take a look the textbook and then you will understand better. Right? So, for example, usually make boundary perpendicular to the flow. So we can make for example, this is the flow from left to right. We can make the boundary perpendicular. This is our boundary. Must be perpendicular. Alright. At time t, the control volume and the fluid system coincide. Alright, this is start. Now we begin our analysis. Alright, this is diffuser. And then this is the system. The fluid system move from left to right. This is the fluid system. Remember that as the fluid move, the system will move. As the fluid deform, the system will deform. Alright. So where to locate the control volume? So for right now, we need to consider the control volume coincide with the fluid system. That means it is at the same position. Let's say the dotted line here. is the control volume. Remember what is a control volume? It is a fixed region. It won't move at all. Okay. This is the control volume, CV. Alright. So this is at point 1 and this is at point 2. During delta t, that means after during delta t, the change of time, the system move in flow direction at uniform speed. V1 at section 1 and V2 at section 2. So now it move, the system move, but the control volume stay the same. I draw again. This is the control volume. Remember, control volume always fixed. Alright. However, the fluid system will always move because follow the fluid. Let's say after the delta t, the fluid will move. Okay, this is the fluid will move from. This is the new fluid position. Okay, the fluid will move from here to here. This is the new position of fluid. Alright. So let's say this is section 1. And then this is section 1. And then this is section 2. Alright. So this is at T plus delta T. For example, your T, initial point T is equal to 1. Okay, this is at T. For example, this is T equal to 1. After the change of time, maybe it is 2 seconds. Okay, it moved within 2 seconds. So 1 plus 2, 3. So the 3 position, the time at 3, it will become like this, the blue color, the new position for fluid system. Alright, the fluid will still move from V1 to V2. So I would like to highlight, right, the I is a region uncovered during delta T. Yes, of course, during delta T, the region uncovered by the fluid system. For the 2, region 2, new region covered by fluid system. Okay, however, it is not part of control volume. Remember, the control volume must be the purple color. Alright, purple color. At time t plus delta t, now it is 1 plus 2, for example, 3 seconds. The system has the same fluid. Remember, the system will always follow the fluid, but it occupies the region. The region of what? Okay, now let's subtract. This is control volume. Where is the control volume? Yes, this is control volume. You need to minus with I. Okay. And then you need to plus with second region. This is occupied by the new region. Okay, this is for system. Alright, I hope you understand, yeah. So I mention again.
Region yang mana kalau CV minus 1?
Okay, untuk region, okay, for the new flow, okay, for example at T plus delta T, the flow move lah, yeah. The flow move from left to right. Okay, CV minus I plus minus region 1 plus region 2 is the new system region. Okay, so the new system is the blue color, right? This one. This one. Okay, this is system. Okay, this is system. How to get the system region? So of course, the control volume, this one, control volume, right? Minus with this one. And then minus with I. And then you need to plus with this region. Okay, now you understand, class. CV minus I plus minus 1 plus 2.
Yes, doctor.
Okay. Alright. So after you understand the system region, CV minus 1 plus 2, you will get the system. Alright, as the time pass, remember that the CV is fixed in space. Thus, this is B system at time T. For example, we start initial time, we start at 1 equal to BCV at time 2. Okay, do you have any question?
Tak faham B.
Tak faham, not understand which part?
The
Itu
B
untuk
system
apa?
sama dengan BCV.
Okay, good. That is why I ask you, do you have any question? Because I want to see. Do you notice what is B? The B we call as the extensive property. What is extensive property? The property relies on mass and the amount. For example, this is system. You put A, you put B. Now the system become A plus B, right? It is amount. For example, the amount of A is 2 kg. The amount of B is 5 kg. So now it change become 7 kg. So this is extensive property. The different, alright. The contradict of the extensive property is B, intensive property, which is not relies on mass. For example, this is the system. You draw the color blue. You draw, this is blue. And then you draw, this is red. So is it change the amount? No, right? It is the color. Alright, so it will not change the amount. For example, the temperature. Okay. For example, like the color. Alright, you can look at the physical property. Alright. For this one, I want to highlight. Basically, physical property categorized into extensive and intensive. This is relies on the mass. This is not rely on the mass. So let's take a look. The B. This is the extensive property. Maybe you can say like the volume, alright, or like the mass. The
Betul,
mass
kalau
flow.
extensive tu macam dia punya length ke size macam tu.
Which one?
Extensive property tu macam dia punya mass, length, volume, size dia.
Yes. When you look at okay, you try to search example of extensive property. Okay. Okay, intensive property doesn't depends on system size or the amount of material in the system. Okay, that is a intensive. By contrast, extensive property such as mass, okay, this is example like mass, volume, okay, this is like entropy. The property of example of intensive like temperature, like refractive index, okay, density or hardness. Okay. All this is not rely to the mass. Okay. The extensive rely heavily on the mass. So remember CV is a fixed in space. So let's start with the time t. At time t, B of the system, that means the extensive property of the system, you can imagine lah. The extensive property can be mass, volume, entropy, alright, that change with mass. Okay, for the time being right now, you need to imagine the B as the mass, okay? The mass of the system at time t coincide with the mass of the control volume at time t, okay? So, after a few time, t plus delta t, now it begins to change, alright? By following this formula. So, B of the system at time t plus delta t equal to B control volume at t plus delta t. Okay, remember we start with CV minus, okay, minus with B of the at region I, okay, at t plus delta t plus B at region 2 t plus delta t. Okay. Plus B at region 2 t plus delta t. Okay, this is the same as this one, yeah? When we want to mention for the time t plus delta t. Okay, for this one. T plus delta t. How to get t plus delta t? Of course, the new region, CV, the fixed region minus I, minus region 1, plus region 2, you will get the blue color. Okay, I hope you understand, yeah? The blue color now represent the T plus delta T. This is how we get lah. Okay, any questions so far? You understand, class?
Yes, Doctor. So
Yes.
dia sama je lah. Kita cuma masukkan intensive property punya.
Masukkan sahaja, just include the extensive property, but the time now different. We look at the time. This is at time t. Dia coincide, betul tak? Coincide.
Betul. Itu awal-awal.
After the time t plus delta t, dia move lah. That means the system, the fluid system start to move. This is the new region. So how to get the new region? B system at t plus delta t equal to control volume minus region 1 plus region 2. Clear?
Clear, Doktor. Doktor cuma nak tanya, macam control volume tu kita yang tentukan Saya lupa pula tadi.
Which one?
Yang control volume tu kita yang tentukan ke atau macam mana nak tentukan?
Control volume tu we decide as we decide and make sure it is first it coincide with the fluid system at the initial point, and secondly the boundary must be perpendicular to the flow lah. For example, if the flow like this, the control volume should be like this. Okay, it's okay. Later on, we're gonna have the example. You can see how you decide the control volume. Okay, so based on at time t and time t plus delta t, okay, subtracting the first equation from the second one and divide with delta t. That means I want to this one. Okay, I want to subtract. So t plus delta t minus, okay, so my intention is t plus delta t minus with t, and finally I want to divide with dt. Okay, I want to divide with time. So let's begin our division. Okay, so B of the system at t plus delta t minus B of the system at time t. Remember this one? I divide, I subtract. Okay, the bottom subtract at the t. Okay, and then equal to B control volume at time t plus delta t minus with B CV at time t. Okay, I subtract this one. And then this is nothing, only B region I t plus delta t plus B2 t plus delta t. So I divide all this, the left and the right side, with delta t. So taking limit delta t approaching 0 and using the definition of derivative. So basically this is the change of extensive property d B of the system over with dt. Equal to, this is the change of control volume. So dB of control volume over dt minus, this is bi dot plus b2 dot. Dot mean over time. So you realize that at region 1 it is inlet, and region 2 it is outlet. Okay, so I can change this one to be inlet and to be outlet. This is a Renault transport theorem. So now letting the intensive property equal to B over M. Alright, how I get B over M? Alright, remember that the extensive property relies on mass, right? So in order to make it equal, we must put constant here. So now I put my constant as equal to constant. I put the constant as a B. So now B become intensive property. And this is extensive property. Now you can see the correlation. So in order to get B, intensive property, B divide with mass. So you will come in this one. And B of control volume. Okay, this is the change of B inside the control volume. Alright. This is the integration of rho B dV. So rho dV is basically equal to dm, because rho equal to mass over volume, right? So in order this one multiply, you will get rho V equal to mass. So this is D, this is D. Alright, the density is constant. The change is volume and the mass. So that is why you put rho dV equal to dm. Alright. So, and here, okay. After that, I substitute into the system. dB of the system over dt equal to this one. D over dt. Okay, integrations of rho B dV. Alright. Let me explain. This is equal, right? You can see B CV equal to rho B dV. This one refer to dm. Okay, and then this is B. So you can see this is B equal to capital B equal to small b multiplied with mass. How to remove D? We must integrate. So that is why BCV integration of B dm is rho dB. Alright. So that is why equal to this one equivalent. So I substitute in the expansion form. Okay. Minus with B1. Okay, this one, yeah. Okay, remember that the B is, capital B is a B multiplied with mass. This is B1 multiplied with mass. Okay, over time. You can see this is dot product. That means mass over time. Okay, or you can put this way lah. Over dt. Plus B2 mass 2 over dt. We know that Okay, we know that mass, all right. Okay, we know that the mass is, all right, rho, all right, this is the density, rho, sorry, rho multiply with volume, right? So in order to get mass, rho multiply with volume. So rho multiply with volume, I change into velocity. So velocity, all right. Sorry. Velocity multiply with delta t multiply with the area. Okay, why? Because velocity, the unit is meter per second. The time is second. And the area is meter squared. You can cancel out second, you will get meter cubic. Meter cubic refer to volume. So, I want to substitute into here. So, dB of the system over dt equal to d over dt integration of rho b dv minus with this one b 1. Okay, start with the mass rho rho 1. Okay, velocity 1 delta t. Okay, delta t multiply with the area 1. This is divide with, okay, divide with delta t lah. Because this is the same lah. Delta t, the change of time. Okay, plus this one lah. B2, rho 2, velocity 2, delta t, area 2 divide with delta t. So now I can cancel delta t, and delta t. So what do I get here is basically d over dt integration rho b dv. Okay. Alright, and then minus b1 rho 1 v1 a1 plus b2 rho 2 v2 a2. Alright. So this term basically we call as, not this term. Yeah, this term is a mass flow rate at 1 and this term is a mass flow rate at 2. Alright. As I expand before, this one, okay. This one I expand here, you will get this one. So the above equation, the above description use one inlet and outlet. Okay, this one inlet, we have a nozzle, this is 1 and this is 0.2, we have the flow. This can apply to this equation. Consider we have multiple inlet and outlet. We have the control volume and then we have the inlet and then we have outlet. We have inlet, we have outlet, we have multiple of inlet outlet. So this is control volume. So this one, the flow must be perpendicular. So it is normal vector. Okay, normal vector. So the n here is a unit vector that point out from the CV. From the CV. Okay. The flow rate of property B through dA is, this is the A. When we look at here, this is the A, the change of A. Okay, is rho B velocity normal dA equal to B out minus B in. Okay, so our Reynolds transport theorem for the extensive property now become the change of time integral with rho B dV plus integral control surface rho B V dot N dA. Alright. So you can see this is the same as this one. The same one, nothing changed. But this one we change. This refer to the surface. We call as a control surface. Why it refer to the surface? Because we have the area. So, in order to simplify the equation, the change of extensive property for the system is equal to the change of control volume. Okay, you can see control volume plus the integral of control surface with respect to area. You can see we have the surface which is dA. If we have many areas, for example, 1, 2, 3, 4, 5. So we will have 5 components. Because this is dA1, this is dA2, this is dA3, dA4, dA5. Alright, you will have 5 components. However, control volume will be the same. Alright, this is only the general extensive property. Now, let's take a look if we consider the extensive property now become the mass. Okay, so let's say we deal with the conservation of mass. So our extensive property B equal to mass. So recall dB of the system over dt equal to dB of the control volume over dt minus with B1 M1. This is the small b lah. I change into capital B divide with mass rho 1 V1 area 1 plus B2 over mass 2 rho 2 V2 A2. Okay, where did I get? From here lah. Which one? Okay, from here. Okay. Okay, from here. So let capital B now extensive property equal to mass. So I want to substitute only d mass Okay. Over dt equal to d mass control volume over dt minus B1 is a mass 1 over mass 1, rho 1 V1A1 plus M2 over M2, rho 2 V2A2. So we can cancel out this one. Alright, for conservation of mass, m dot equal to 0, right? As I mentioned before, the m dot for the system equal to 0. Which one? The one that we have based on the conservation of mass. Okay, conservation of mass means the mass of a system conserved. So D mass, the rate change of mass in the system equal to 0. So from here, where equal to 0? This term lah, equal to 0. Alright. So now it becomes 0 equal to, okay, the volume differentiation of rho CV over dt. This is the same, yeah. This one, volume multiply with density is equal to mass. Okay, but the difference now, the change is the density. Why the change in density, the volume become fixed? Because this is considered a fixed volume and the fluid is considered compressible or incompressible. So it change in density. Minus with rho 1 V1 A1 plus rho 2 V2 A2. You can see density 1 and density 2 change different. That is why we have to do the differentiation of the density. Okay, to ease your understanding, let's say this is the nozzle, we have the flow. Okay, the nozzle, the volume of the nozzle still the same. This is control volume. But now the change is the system. So the density change. Density here might be different with density here. That is why we have the change of density, differentiation of density. Alright. We can rearrange this equation. We will get V d rho CV over dt equal to rho 1 V1 A1 minus rho 2 V2 A2. This is we call a continuity equation. This is inflow. Okay, sorry. Okay, sorry. Okay, this is in. Yeah, rearrange the equation. Okay, this one, all this move to the left lah. So it will become, betul lah. Rho 1 V1 A1, okay, minus rho 2 V2 A2. So this is become the inflow and this become outflow. Okay, we can write in integral form. So 0 equal to, okay, d over dt, this one, yeah. Okay. Control volume rho dv plus control surface rho velocity average dot normal vector multiply with the area. This is for the conservation of mass. So the above equation is 1D. We have inlet and outlet. If not one-dimensional, if not 1D, m dot here found by taking integral of. Okay, this one continue. Wait, we have to continue. Okay, if the condition under steady state, there is no change of property, only change property over time. That means anything pertaining to the time equal to 0. So this we can cancel out. We'll get only 0 equal to control surface rho v dot n dA. Alright, if we only consider inlet and outlet, okay, we can do the expansion. Okay, rho, for example, we have flow 1 and 2. Alright, we have the mass lah, for example. So rho 1, okay, you can put integration from 1 to 2. Okay, so rho 2 V2. Okay, and A2 minus rho 1 V1 A1 equal to 0. So you will get rho 2 V2 A2 equal to rho 1 V1 A1. Okay, this is basically equal to mass flow rate. Mass flow rate. Okay. You can also put the normal vector. Alright. But now we consider this one should be normal. Always normal. Normal to the area. So the above equation for 1D only. If more than if not one dimensional, we must do the integration of this one. Control surface, it will be control surface rho v dot n dA. This one lah, the same thing as this one. Okay, if we have so many, we have multiple inlet and outlet. For example, we have flow. Okay. Can you give example? What kind of flow that you can see in your daily life, that you can think in your daily life, that involve inlet 1, inlet 2, inlet 3, outlet 1, outlet 2, outlet 3, so many. Can you guess? Any application?
Blood vessel.
Okay, blood vessel. And then? Alveoli, right? In our lung. Okay, to exchange oxygen. We have the blood vessel. All these require the fluid mechanics that you need to solve. Okay. So if the change of density is very small, that means it is incompressible. So we can neglect the change of density, which is control volume lah. Okay. dV terms and gets dA is equal to rho control volume. Sorry. The rho now become constant. It is no change over time. For example, this is under incompressible. That means it is very hard to compress like water. Okay? But you must understand at different temperature, it might compress as well. All right. If at the room temperature, it is hard to compress. So when the density become constant, it is under incompressible. So now it will become control surface. Sorry. The density we move outside because it is constant. Come rho control surface V dot N dA equal to 0. Right. So from here, V we move outside. Okay. Now it become dA equal to 0. If we have one inlet and one outlet, consider this is point 1 and point 2. So V1, V2, okay, V2A2 minus V1A1 equal to 0. So V1A1 equal to V2A2. Alright. Or we can make sure this is the inlet. Okay, 1 as the inlet as the summation. Okay. Summation of inlet equal to summation of outlet. Okay. Or so V multiply with area, velocity. So the unit of velocity is meter per second. Multiply with area, meter squared. So the unit is meter cubic per second. You can see meter cubic is volume, right? So it is volume. So volume divide with time. So it become volume flow rate. Or when you have put the Q, no need to put the dot. It's already well known. Is a volume flow. Volume flow rate. Okay, so here Q out equal to Q in. Okay, let's take a look at example 1. Okay. The inlet section of vacuum cleaner is rectangular. Alright. So for example, we have a rectangular vacuum cleaner. Okay, this is inlet. And this is outlet. Alright, the inlet section of vacuum cleaner. Alright, this is a vacuum. Okay, this is vacuum. Sorry. Alright. We have the area lah. Alright, the area is 1 inch by 5 inch. The blower can provide suction at, this is Q. Okay, this is volume flow rate, 25 cubic per minute. So the question, find the average velocity at the unit of meter per second. So our assumption now, start with assumption. The air is incompressible. When it is incompressible, the density is constant. Okay, we can use the formula of Q equal to AV. Alright. Q is a volume flow rate, A is the area, and V is the average velocity. So we can get the average velocity Q over area. So we must convert the flow rate first. Q equal to 25 feet cube per minute. We need to convert into feet cube per second first. Alright. Multiply 1 minute divide 16 second equal to 0.417 feet cube per second. And then we need to get the area in equal to 5 inch multiply with 1 inch. You will get 5 inch squared. So I want to convert 5 inch squared into feet squared. So multiply with 1 feet equal to 12 inch. I squared it because this is squared. I will get 0.0347 feet squared. So the same unit now, feet and feet, I can directly multiply with V in. Q in. Okay. Area in 0.417 feet cube per second over with 0.0347 feet squared equal to, this is feet squared, cancel with this one, you will get 12.01 feet per second. Alright, now I want to change feet into meter. So 1 feet or 1 foot equal to 0.3048 meter. So I will get 3.66 meter per second. Alright, this is basically involved of unit conversion lah. Alright. The question asks, the second question, if condition at sea level, what is the mass flow rate? Okay, the mass flow rate. Right, this is A, this is B. How to get mass flow rate? Which is the formula rho A V. So A and V is a volume flow rate. Okay, under the sea level, which is H equal to 0. Okay, you can look at the table and you will find directly the density. Okay, the density of air under the sea level is equal to 1.2255 kilogram per meter cubic. So from here, I want to change my Q into SI unit because this is already is the SI unit, right? Kilogram per meter cubic. So Q here is, you can see 25 feet cube per minute. 25 feet cube per minute multiply with 1 foot equal to 0.3048 meter. Cubic. Okay, and then multiply with 1 minute 16 seconds. So cancel. You will have 0.0118 meter cube per second. Thus, the mass flow rate now become, the rho is 1.2255 kilogram per meter cubic multiply with the volume flow rate, which is 0.0118 meter cubic per second. So meter cubic, you will have kilogram per second. Okay. Any question? Class? Alright, I think that's all. What I want you to do after this is to give your feedback on your understanding integral form. Alright. The next class we're gonna review the test. We're gonna review the question that will help you in the task 1. Okay. Okay. As usual, I would like you to go to e-learning. Go to your own section. Okay, give your feedback on your understanding integral form. What have you learned? Okay. Okay, so now this is a week. Okay. Okay, I create the forum. What have you learned on, let's say, the Reynolds transport theorem? Conservation of mass. Conservation of mass. Okay, please give 5 points with example. I will review. Okay, what have you learned? I give you 15 minutes, yeah? Okay, section 15, you may start now. Section section 16, you may start. We're going to review together. Give example, 5 points at least. Okay. Please, all the sections start now. I give within 15 minutes. After that, we're going to review together. I want to make sure you understand the subject clearly. Okay, go to your own section and write your name as the subject, and please give at least 5 main point with example that you learn on Reynolds transport theorem and conservation of mass. I give you 15 minutes from now. Okay, I give you 10 minutes lah. Alright. After that, I'm gonna have the we're gonna have the breakup session, and then we can see you need to contribute your idea. What have you learned? If you get as many point as you go through, okay, you will be the advantage lah for you. Okay, I give you 10 minutes, okay, to write down at your e-learning, and then we're gonna have the breakout session. And after that, you need to assign a moderator or the team leader. So within 20 minutes, all of you need to contribute what you have learned, all right, as many points as possible. Okay, class. It's times now. Uh, please go to the Jamboard. Okay. Before that, I will assign you to 5 group. Okay. Can you see my screen, class? Class, are you there?
Yes, Doctor.
Okay, can you see my screen? Okay, I will assign all of you into 5 room 1 until room 5. So you need to give as many points as possible on what have you learned on Renault transport theorem and conservation of mass. All right. So you can use this one, the text button. Click text button and write. Okay, point 1. I learned on extensive property is what? Okay, extensive relate to mass. Example mass volume. Okay, so you can reduce the size to be the caption. Okay, give as much as point. Fill up all these components, all the page. All right. Okay, I give you within 20 minutes. Please discuss with your friend, collaborate, and contribute idea. All right. Now I will assign you to the 5 group. Okay, please click accept. Okay. I will send you the share link in the WhatsApp. Okay, Jamboard. EVT. And 15 to 18. All right. Are you able to log in, class? Okay. Now I give you within 20 minutes. Please discuss and contribute as many ideas as possible and fill up the page. Okay, you may start now. I create the room now. All right, class, time's up. All right, I can see now. What have you done? Okay, let's review. Room 1. Intensive property rely on mass, correct? All right. If there is only one exit, one entrance, yes, you can use. This is rho AV, all right, not pressure. RTT is used to convert from system, yes, correct. And then, okay, good. We go to room number 2. Conservation of mass doesn't change with time. Yes, good. And then the mass flow rate, RTT used to convert from system to control volume. Yes. Okay, room number 3, quite nice. All right, we have colorful notes. Control volume is a boundary of the first region of fluid system. Okay, how do you get this picture? Yeah. Okay. May I know who did this picture?
Hello.
Hello. Right.
Saya ambil
Where do you get this picture?
Google.
Oh, okay. Is there any reference from
Sekejap tengok.
Okay, it's okay. I want to know the reference, okay, so that I can look at clearly. Okay, this is also the same lah. Why the same? Is it the same person? Room number 5. All right. Okay. I think that is very wonderful. Okay, and then excellence of the note, colorful. All right. What I want you to do after that, go to your forum. Okay. Some of you have done, yeah. Okay. If you think you are not done yet, okay, add new discussion. Your name, okay, Ali, and the message here, please screenshot. Okay, screenshot. Which room do you prefer? Maybe you want room number 3. Okay, screenshot room number 3 that you think you can understand, and then paste in your, okay, this one, and then post to forum. All right. So this is for those haven't done yet. Okay, this is very important. During the final exam or during the test number 2, you're gonna refresh what have you learned. So you can look at the e-learning, what you have post, and then you can learn from that. Is it okay for those haven't done yet? All right, I think that's all for today. Thank you very much. Please do so. I can see maybe some of you haven't post yet. What have you learned on Renault transport theorem? Okay, this group got only 5. Okay, group 17. Group 17, I'm not sure. Still got student or not? No. Group 16. Okay, if you haven't done, please copy and paste only. That is very simple. We can see Hazim. Okay, excellent Hazim. Excellent all of you. Thank you very much for your contribution, yeah. All right, for the next class, we're going to continue on discussing the assignment. All right, assignment question, assignment 3.
Doctor,
Yes.
can you
The
please share
QR
the
code?
QR code?
All right, sure. All right, class, I think that's all for today. Thank you very much for your time. I end my session with Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Good,
Okay, welcome.
Thank you, Doktor.
Okay, welcome semua.